Over the last several weeks, we have learned that we inherit our traits from our parents, and those traits are passed down to us through the genes. So what happens if you inherit a gene that can cause a genetic disorder? In this lesson, we will learn about genes and hereditary disorders. Be prepared and ready to explain what you have learned in your cooperative group. Please take notes in your science journal. Thank you.
A birth announcement is always good news, but for me it's more than that. I'm a genetic counselor. I first met Frank and Sarah a little over a year ago.
My obstetrician wanted me to see you.
I don't know what the problem is. We have 2 fine, healthy kids, and we want to have another. But he says she's too old.
He didn't say that. He said there might be higher risks at my age. I'm 36.
Well, I'm glad you came in. Certain birth defects are more common in children born to older mothers. But that doesn't mean both of you can't have another perfectly normal child. Let's talk about it. In the nucleus of each human cell, there are structures called chromosomes. Each cell has 46 chromosomes, comprised of 23 pairs. When sperm cells are formed in the testis, the 46 chromosomes are divided, and each sperm cell ends up with 23, half the original number. A similar process takes place when an egg cell is formed in the ovary. Now, when a sperm cell fertilizes an egg cell, the 23 chromosomes from the father join the 23 chromosomes from the mother and make a cell with 46 chromosomes again. So we receive half our chromosomes from our mother and half from our father, and that mixture is reproduced in all our cells.
Oh, well, we know about that, but what does all that have to do with her being too old to have a baby?
Under a microscope, each chromosome can be identified and assigned a number. Sometimes the fetus gets an extra chromosome, an extra number 21 chromosome, for example. Now, the chance of that happening seems to increase with the age of the mother. When the fetus has an extra number 21 chromosome, the child will be born with Down syndrome.
Down syndrome? That's mental retardation.
One cause of mental retardation, yes.
What are the chances of that happening?
Down syndrome is the most common serious chromosome defect. A Down syndrome child can be born to mothers of all ages, but the chances increase with age. At 36, the chances are about 1 in 100 for some type of chromosome disorder to occur.
Well, it's not so bad.
Everybody looks at risk differently. Some would see it high, some low. Medically, it's considered an increased risk, but the important thing is how the two of you see it.
They don't live very long, do they? The children with Down syndrome.
Their life expectancy is generally longer than it used to be, but they have high rates of serious problems, such as heart defects and digestive tract abnormalities, and they often die by middle age.
And they're mentally retarded.
Yes, mental retardation is always present, but how severe it is varies.
Then I shouldn't get pregnant, should I?
You have to make your own decision as a couple. But in order to make a decision you're comfortable with, you need more information. Now, the chances are in your favor at any age for having a normal baby. But because of the higher risks for chromosome problems at later ages, there are options available to you that can rule out some problems in the baby during the pregnancy. Skin cells which flake off the fetus float around in the amniotic fluid in which it's developing. At around the 16th week of pregnancy, some of the fluid can be removed by a process called amniocentesis, and some of the cells can be collected. There's another test called chorionic villi sampling, or CVS, in which a tiny bit of tissue is taken from the membrane surrounding the fetus. It has the advantage that it can be done earlier in the pregnancy, at 8 to 11 weeks, but it presents a somewhat higher risk of complications. Cells collected by either test are grown in a lab and studied. If the extra chromosome is found in the fetus's cells, then you'll know that the child will be born with Down syndrome.
So then I can stop the pregnancy.
If you choose to, you might seek to have it medically terminated. But whatever you choose, it's important that the two of you reach your own decision. The first phone call came several months later.
Frank and I talked it over after we saw you, and we came to a decision. We decided to go through with it, and I'm pregnant.
Frank and Sarah and I discussed the benefits, risks, and limitations of CVS and amniocentesis. They chose the amniocentesis. And then it was my turn to phone.
Hello?
Sarah, this is Jane Wilson. The tests are back from the lab. The chromosomes are normal.
Does that mean that my baby doesn't have Down syndrome?
That's right. The tests also tell which sex the baby is. Would you like to know?
Yes.
It's a boy.
Honey, it's a boy. It's a boy.
We just got married.
We just got back from our honeymoon.
And the rabbi told us that we should come and see you.
Something about something called Tay-Sachs disease?
What is it?
We feel fine.
Your rabbi's concerned about your children. Are you planning on having children?
Yes.
Okay. Well then, let me tell you about Tay-Sachs disease. It's hereditary, and it's transmitted by a recessive gene. Now, the chromosomes in our cells are made up of DNA. DNA is a thread-like substance, shaped like a long, twisted ladder. The rungs of the ladder are made of 4 different chemical units, 2 units to a rung. The varying sequence of the different kinds of rungs makes up a code in which all our genetic information is recorded. It takes 500 to 2,000 of those rungs to make a single gene. Now, each chromosome is made up of many genes, and each gene carries an element of hereditary information from one generation to another. When a sperm cell is formed, the chromosomes pair up, and some of the genes are randomly exchanged. At that time, each chromosome may contain a mixture of the genes from each of the man's parents. The cell then divides twice, resulting in 4 new cells, each containing a unique combination of chromosomes. Each egg cell also has its own unique combination. So your baby would be half you and your ancestors, and half you and yours. Some genes are dominant, like the one for a dimple on the chin. If the baby inherits that gene from just one parent, the baby will have a dimpled chin. The codes for some genetic defects are carried on dominant genes. Huntington's disease, for example. Other genes are recessive. A trait carried by a recessive gene won't show in a child unless it inherits the gene from both parents. The gene for Tay-Sachs disease is recessive. That means it takes a Tay-Sachs gene from both the father and the mother to transmit the disease to their child.
Then what's the problem? Like she said, we're fine. We don't have it.
If you had it, you wouldn't be here. Children born with Tay-Sachs seem normal for the first 6 months or so, and then they begin to regress. They develop seizures and blindness and deteriorate mentally and eventually die, usually when they're between 2 and 5 years old. Well, you don't have it, but you could be carriers if you have just one gene for Tay-Sachs in your cells.
But why us? Why do you think we have it? Why did the rabbi tell us to come see you?
Yes, does he know something we don't?
You're both Jewish? And your ancestors on both sides came from Eastern Europe. Is that right?
That's right. How'd you know that? And what does that have to do with Tay-Sachs disease?
Jewish people with roots in Eastern Europe have around a 1 in 30 chance of carrying the gene for Tay-Sachs.
I don't understand.
A couple who were here earlier said the same thing.
I don't understand.
Neither do I. Why do you think that we might be carriers for sickle cell anemia?
We're not sick.
We feel fine.
Sickle cell anemia is a genetic disease that deforms red blood cells so they can't carry oxygen normally. It's carried by a recessive gene. Black people of African origin have a 1 in 10 chance of having that gene.
But why us?
Certain genetic diseases are more common in specific ethnic groups. In the Caucasian population, there's a 1 in 25 chance of carrying the gene for cystic fibrosis. Now, that's a disease that causes lung infections and intestinal problems. What happens is that the same genes tend to get concentrated in the cells of groups of people who have kept together and intermarried over a long period of time.
Like cousins marry.
That's more extreme, but yes.
So what are our chances? What if we both have the gene for Tay-Sachs? Will our kids have the disease?
If you're a carrier, you'll have the Tay-Sachs gene in half your sperm cells. If your wife is a carrier, she has it in half of her egg cells. Statistically, if both of you are carriers, the chance that a sperm and an egg with the genes for Tay-Sachs will be paired is 1 out of 4. That makes it a 25% chance that your child would have the disease.
Well, what do we do?
First, we should make a family pedigree. That's a family history that lists all the relatives you can trace or remember in both of your families. That way we can find out if there's a history of Tay-Sachs or any other genetic disease. The absence of it wouldn't guarantee you're not carriers, but its presence would be an indication that you might be. I'll start with the 2 of you and work back in both your families as far as you can. A square for a male. It's you, Jerry. A circle for a female. Ruth. Your mother and father, grandparents, both sets, a slash if they're deceased, aunts and uncles, cousins, brothers, sisters, nieces and nephews. Now, do you know of anyone who died at an early age, perhaps in early childhood?
There was a cousin on my father's side.
I think I had an uncle who died when he was 3 or 4.
We'll have to ask questions and find out.
Ruth and Jerry went out and asked questions in their families and collected medical records. 2 early unexplained childhood deaths in Jerry's family, and 1 diagnosed as Tay-Sachs and Ruth's. Given your ethnic background, you should be tested to see if you're carriers. It's only a blood test.
Now what do we do? We're both carriers. And I'm already pregnant. I didn't know that when I came before. should have taken the test earlier.
There are 3 chances out of 4 there's no problem. You can have an amniocentesis or a CVS to find out. The test came back positive for Tay-Sachs.
What would you do? What do other people do?
What other people do isn't important. You're the ones who are going to have to live with this decision.
I don't want to bring somebody into the world to suffer and then die and never feel good or have any fun. I just couldn't stand it. It wouldn't be right. I don't want to do that. I had to write and tell you. We're happy in our new home out here, and Jerry loves his job, and I'm pregnant again, and I've had my amniocentesis, and the baby's okay. He doesn't have it. Thank you. Thank you for everything. I'm scared.
So am I.
We really want to have a baby, but
All the things you read about and hear about. I mean, retarded kids, kids with no arms, kids kept alive on machines.
and the things in the environment, the pesticides, lead, x-rays, viruses, German measles.
Her doctor said we should come and talk to you.
I'm scared, and I think I have good reason to be scared. I don't want to give birth to an abnormal child.
I can understand your concern, but let's put it in perspective. It's true. 3 to 4% of all children born are born with a major birth defect. Among the common genetic diseases are Down syndrome, cystic fibrosis, spina bifida, dwarfism, and muscular dystrophy. But that means that 96 to 97% of all children are born normal and healthy. As long as there's no family or personal history increasing your risk, and if you receive proper medical care during pregnancy, the odds are way in favor of your giving birth to a normal child.
Well, that's okay, but it's not the odds I'm worried about. I'm concerned about...
It's understandable to be concerned about the other 3 to 4% risk. That's a risk all prospective parents face. And there are ways of ruling out higher risks.
Oh, what kind of ways?
First, the 2 of you can make a family pedigree. Find out if there's any history of genetic disease in either of your families. There may be special genetic tests available to you. There's also a device called ultrasound that makes it possible to see a fetus inside the womb and sometimes determine if there are any gross physical abnormalities. But there are limitations, and the accuracy of this technology varies. Sometimes the body takes care of itself. A miscarriage is possible.
Well, I don't want to have a miscarriage.
Oh, of course you don't. But 40 to 60% of all fetuses studied after being miscarried show signs of serious genetic abnormalities. It seems that our bodies often put a stop to pregnancies with fetal defects. Do you drink?
Beer, sometimes.
What about drugs, like marijuana, cocaine, heroin?
No.
Nothing.
Good. Many genetic birth defects are multifactorial. It means that a combination of factors makes them happen. The fetus is extremely vulnerable to outside influences. Starting in about the 3rd to 4th week, various organs begin to develop. If a harmful outside influence is introduced when a specific organ is under development, or there's a deficiency in an essential nutrient, then that part of the fetus may become abnormal. Pregnant women who drink heavily have a high risk of delivering a child with a combination of birth defects called fetal alcohol syndrome. It's a common cause of mental retardation.
Well, I don't have to drink beer.
Okay. Are you diabetic?
No.
Epileptic? Do you have any other illnesses for which you're taking medication?
No.
Some medicines cause birth defects. There's a medicine many people take to treat acne, for example, that can cause serious problems. Before you become pregnant, it's important to tell your doctor about any medicines you're taking.
Okay, so there are things we can do. But what if we have a child with a birth defect anyhow?
If you did, there are medical and social service people to help. There are also support groups, people with the same problem who can offer you their experience and encouragement. And there are newer and better ways to help a person with special needs become a valued member of the family and the community. But you need to be aware of both sides. Good home and medical care is often extremely expensive and not always readily available. And there can be sorrow and continuing hardship for the parents and for the other children in the family, as well as pain and suffering for the affected child.
And there can be love and hope. What if our parents hadn't taken the chance with us?
I haven't had a card or a note yet from George and Maria. Maybe I never will. But I'm glad they came. We're learning a great deal about birth defects. In the future, some genetic diseases may even be curable with gene therapy. In the meantime, it makes sense to make use of what we've already learned and what we're learning so that we can make the choices we have to make.